is Tomer. I'm the L&D group leader of active testing. Active testing is our solution to continuously test your APIs for vulnerabilities before they hit production by adopting the shift left approach. In a word, before we start, active testing is a DaaS platform that was designed to be API first. It is meant to be easily integrated inside your shift left solutions to provide security insights over your APIs during the development, the QA phases, and it holds some super sophisticated mechanisms to achieve full testing coverage of every API you develop. This is something that makes us super unique, and this is done completely automatically thanks to some industry-leading business logic analysis algorithms that we'll talk about today. That understands your applications, learns how to interact with the API successfully, and then attacks them with many business logic centered attacks. We're going to cover it all today. We're going to do a demo about it. So why cannot? Okay. So as I said, today we're going to do a brief overview about our solution. We're going to talk about the need for shift left in API security, how it completes our security offering. We're going to talk about why a DaaS platform is the correct solution inside your shift left processes. We're going to talk about the challenges it brings to the table, the ones that we were required to overcome while developing active testing, and of course, how we approach them. And then we're going to do a live demo of the platform of our most recent version, Active Testing V2. So let's get to it. I think we'll start with a little bit of shift left. So today, the industry understands that the shift left approach is crucial for optimizing development processes. We all know that early detection and mitigation of any bug or problem during the development process itself is beneficial in order to reduce costs, risks, response times. And this goes the same for security, and the world is starting to accept this as well. More and more cybersecurity solutions are trying to achieve the same effect. They want to detect the vulnerabilities before the code hits production. And this means we want to provide security insights over your CI/CD pipelines that represents different code branches, over staging or QA environments, or even your developers' personal computers and IDEs. And today, we all have the understanding that any security risk exposed in production is a ticking time bomb. Early identification and mitigation of vulnerabilities reduces impact, reduces cost, reduces response time, and adopting shift left solution to your security arsenal adds an important layer of defense in your layer defense strategy, which is, of course, super healthy. You might be asking why a DaaS tool, why a dynamic application security testing tool would be the most beneficial tool for achieving security value in shift left. To answer this, we need to think, how does pre-production environment behaves different from production environments? So first of all, on non-production environments, there's no massive user interaction, which is being utilized in the core platform that Edgar just showed you. And we can learn from this traffic about the behavior of the application and therefore provide relevant insights about your security posture. So a solution that captures traffic and tries to understand your security posture while identifying attack attempts is irrelevant for these kinds of non-production environments. Secondly, the infrastructure in non-production environments, the server hardenings, how they are connected, how they are deployed, most of the time during the entire shift left story of developing an application will differ from the production infrastructure. Therefore, the main focus should be the security value should be on the common ground between the environments, which is, of course, the business logic of your application or the code of the application. And these are the ones that we want to challenge. This is the underbelly of your application. And this is the thing that we want to investigate with active testing. So we understand that the correct approach would be a proactive one. We should simply ask the relevant questions, talk with the APIs instead of waiting for answers to appear in traffic in non-production environments, or read them in logs or configuration, just like a normal DaaS platform does. Also, asking the question enables us to tackle what is important, what truly matters for your developers, as we said, the business logic flow. Any questions before I continue? Perfect.
Yeah, how does the information you learn about how the API is used in production help you in doing this testing side of the affair?
Oh, that's an amazing question. We, of course, utilize the fact that we have the production solution, and it gives us many insights about how to treat the APIs in pre-production. And we're not even talking only about how to consume APIs that appears both in pre-production and in production, but we'll talk about it in a moment. Active testing truly understands what resources your application works with. It works with orders, users, branches, pharmacies. I don't know. The thing is that it understands the resources, and we communicate between production and non-production over these resources. I can understand how a specific resource should behave. Maybe it's a publicly accessible resource. Maybe it's a private resource that should be assigned to a single user. And we take these conclusions and transfer them to pre-production, where you always meet new APIs. But the resources usually stay the same. So I can take these kinds of insights and make my tests more accurate. Maybe in Ebola, for example, a test for a resource that is accessible with one user and it was created by another user. We'll see it in a moment. I can take this resource and state if it is public or private by examining traffic in production. Stuff like this. We do many of these transfers of data between the two. Okay, so I just wanted to talk for a brief moment about the challenges we needed to face while creating this active testing platform. So we want to test to first we want to ensure coverage. The most important thing, in my opinion, as part of understanding what assets we're trying to secure, right? Which APIs we want to protect. In Shift Left, the discovery could be completely automatic, of course. So it has to be super accurate. You shouldn't leave any API untested before it leaves production. Sadly, many desk tools that you have currently offered in the industry leave this challenge behind and do not face this technical challenge, which is super complicated. Web desk platforms, if we'll investigate, for example, a Zap proxy, which everybody loves, relies on crawling to ensure every possible page is tested, right? This is, of course, suboptimal because the crawling process does not necessarily fully covers the web application. You cannot guarantee that you met every page and tested it, especially when you integrate this kind of tool in Shift Left. It should be completely automatic, shouldn't be exposed to this. And at least most web desk tools show us the tree of assets detected, and you can provision it later on. And on the other hand, API desk platforms relies on the application specifications like OpenAPI specs, Swagger files, which may not be as accurate as expected. Usually they are not accurate. Not only lacking examples or stuff like this, but the schemas are inherently wrong. And this could happen. This is because they were made for humans and not for an automated machine that needs to rely on this as an input. So how can we make sure no API is left untested? Spoiler, that's, in my opinion, what makes us unique in this field. Secondly, it is, of course, let's talk about the impact, the automation of API security tests. It is hard to create automated security tests that examine the posture of your APIs and disrupt the business logic of the applications without having a baseline of the consumed APIs, the one that you are testing, how it should be consumed normally, not being under attack. Just from the open API specs I've mentioned before, a regular desk platform cannot automatically assume anything about what is the correct way to interact with an API, because there is a minimum standard that all APIs align to. It's a complete jungle. Nobody follows CRUD standards, so we cannot make assumptions based on this. We cannot make any assumptions about the accuracy of the OpenAPI spec itself. We cannot understand anything about the purpose of the API in the world, etc., etc. Everything that will help us bring you some business logic-centered issues. Not only that, but providing meaningful issues as such is hard without being familiar with how your applications work, For example, authorization issues. How can I know if a certain role is supposed to access a certain API? How can I know it as an automatic tool without talking with the developers who created it, without asking them to provide me this map, which does not exist anywhere, and I cannot automate this process? We are not a real life penetration tester, but we strive to provide issues that could be created by a real life penetration tester. Not only, but we need to strike the right balance between creating testing logics that are not too general and not too specific for a certain case. Disrupting the underbelly of the APIs, like I said before, your application business logic flows, uncovering the issue that truly matters for API developer is a truly challenging task that requires some groundbreaking algorithms that we're going to talk about in a moment. And last of all, as you can see here on the third goal, we want to avoid interfering with the development team. We need developers to embrace the solutions into their CI/CD pipelines, which means we don't want the scan process to cause substantial delays that interfere with their day-to-day. We want them to trust our output, so it will be considered and truly affect the development process. I can think about so many tools that integrate with CI/CD solutions that throw so many issues that nobody is even taking a look at them because there are too many. They're not focused, and they usually are junk. So of course we need to gain their trust with accuracy, and we want it to be, of course, simple to use, both by developers who want to gain value from active testing and the AppSec or DevSecOps personnel who interact with it in a different manner. So bottom line, we have here three goals. We need coverage. All API should be fully tested, leaving no stone unturned. We need impact to uncover deep and impactful business logic vulnerabilities. And we need usability. We want it to be simple, fast, accurate, and of course, flexible. So let's talk about the active testing way just before jumping to the demo. We start with an API inventory. The API inventory is being filled by standard development tools. As we've said, open API specs, Swagger files, Postman collections, Rambo files, everything that you can imagine, even a list of curl commands. If you don't have them while developing your APIs, you can always utilize the Noname core solution, the traffic monitoring component of our core solution, to attach yourself to a certain pre-production environment that you want to test and extract the open API specs from there. Then after we have this inventory, we use some super sophisticated business logic analysis tools to understand your application. We understand what your API is meant to do, with which resources it mangles with, how it affects these resources, what are the connections between the APIs. And this is basically the idea of reachability, of consuming your API's business logic successfully before attacking them, just for you to fully test them later on to obtain the baseline that we talked about before. And we do it with some industry leading algorithm that, pardon my French, we're using machine learning, but some purely mathematical algorithms as well. We have, of course, we utilize these same algorithms to later on affect the business logic tests that we run, the security tests. And of course, after the understanding part, we launch tens and tens and tens of attacks over your APIs, which are all covered by, of course, a WASP of 10 for APIs, and also some scenarios that we've learned as a company that our customers experience. Some attacks that are not mentioned in the classic categories, but we see that are very, very common. So this is the flow of how active testing does, from analyzing the input and then understanding the baseline of the API and then attacking it. And of course, this entire solution is designed for shift left, as I said. What it means, first of all, it does not look over your application as it has a single posture like in production. In shift left application development is a long story that starts in the computer of the developer, then it goes through some CI/CD branches, then it goes to some staging or QA environments, and they all hold different postures, security postures and assets. You might have different APIs, you might have different security status, And we support it through active testing by analyzing these different chapters in the application's life cycle. And you can even compare the status of the application, the assets, the issues between these different checkpoints in the application's life. Of course, we also enable super easy CI/CD integration, which allows developers to adopt active testing with just a few clicks. We will also see this today. This is active testing. I think it's the most beautiful product that I've ever seen. And and here you can see the application hub. There you have all the applications that you chose to analyze, to test. I just want to share with you how simple the onboarding process is. I just press new application. I give it a name. Let's say Edgar's app. I can. I wrote Edgar's wrong. Edgar's app. Let's say it has a URL where I can test it. For example, customer.com. And then I go over and specify the APIs there, right? So I enter a source name, like source one, and I can choose if I want to upload the file right now. I can provide maybe a URL to access it dynamically during the scan itself, or I can place it as raw text. Let's just put an empty source here, but I just want to mention that we do support lots and lots of input types, as I've mentioned, like Postman collections, etc., etc. We support GraphQL and REST as well. So GraphQL, you can provide a GraphQL introspection or schema. All of this is supported. The tests that are going to be executed over the APIs is not related to the protocol itself. We do have some tailor-made protocol-dependent tests like GraphQL hardenings, but all of the business logic tests does not care what is the protocol because everything is normalized to the same inventory. So after providing the source or maybe multiple sources that represent your application, I go over and define the different users that should access these APIs. Active testing needs this in order to access the APIs that are require authorization to access them. So let's take maybe user one, which is from a role of an admin. Active testing will take the text here and will try to understand how this role connects to the APIs and assume stuff over this. We'll see it in a moment, but I can also write here, pharmacist or something. It does not matter. It's a free text, but let's say an admin for now. And here I provide the different secrets that represent the user inside a request. When I want to interact with an API, I need to add some secrets. So I can place, for example, an authorization header. Let's write here, Bell, EY, and the JWT. And I can maybe add a cookie if I want that I need of some sort of a session ID. And of course, we have dynamic secrets as well. I can retrieve a JWT every time I'm in a scan for you not to be required to update it every time before a scan. Again, we're talking about shift left. We're talking about automation. This is required. So once completed, I have my application and I'm good to go. I can just press scan. This is as simple as that. Let's go to a real application with your permission. This one, for example. So we'll start with the scans page. Here you can see a log of all of the scans that happened in active testing. All of them, by the way, as you can see here, executed with a certain test profile, no name test. These are all of the tests that we've created in-house. But of course, this could be challenged. You can choose by pressing the advanced scan button, you can choose many test profiles that will fit different routines of your organizations. I can create my own custom test profiles. I can change the severity of different tests, etc., assemble something and use this as my test profile. Of course, we have here some super cool presets that you could use. So I can just start a scan. I can, of course, schedule a scan to happen once a day or twice a day by going to the scheduling settings of the application. But the idea here is that we have a log of scans that will be filled over time. The issues that will be raised in each and every scan is reflecting the state of the application right now. The issues should be reduced over time because people are fixing the problems, or they may increase because of new feature in this specific environment that I'm testing right now. And in each and every scan, I have here the issues that were raised. And the idea of active testing's posturability is that all of the data that is being gathered here from different scans that happened in different times, in different test profiles, is being aggregated to three posture screens. Let's start with the easiest one, the overview page. Here you can see a dashboard of your application's posture. You can see stuff like the distribution of issues by OWASP 10 for APIs, by severity, your top 5 issues in your organization for you to learn what are the strategic problems that you hold in your development habits. We have here some coverage data like how many APIs was I able to consume correctly and extract the full business logic that they offer and which are not. This is very important, and we'll talk about it in a moment. We'll see the scheduling config, even with alerts when a scan did not happen as expected by the routine I've defined. We can see here the responsiveness. Once I have some issues that are being fixed here, we can see the fixing time and analyze this, Jira ticketing that are connected to the issues that are raised in active testing. We can see here the top 5 vulnerable APIs, etc., some CI/CD and SSDLC insights. This screen grows over time. We always launch new widgets. But this is, of course, just an overview that you can generate a report from. Let's go to the interesting part. Let's start with the inventory. As a result of a scan, I see here all of the APIs that were detected. They were detected from the Open API specs. We do try to look a little bit left and right and find more APIs that are not mentioned in the spec by trying to run some heuristics over your API spec. And the interesting part here that you can see this little red and green dot next to each and every API. And I think this is the thing that makes it special. This is reachability, the ability to reflect to the customer the coverage of the scan, a thing that most desk tools today avoid because they fail at this. We have this amazing business logic algorithms that try to understand the purpose of an API in the world, and by that, it understands how to fill the correct parameters in each and every API, or maybe even call some APIs before the tested APIs to prepare the correct application state for active testing to be able to consume the API. And then it understands if it completely understood how to consume it by analyzing the return value of the API. This is where we integrate machine learning there. And we provide you this data. We provide you if we were able or not to consume the API's business logic successfully. This is for you to be able to inspect your coverage and even run some mitigations or troubleshooting if required. You can see here that we don't have full reachability. And if I have full reachability for each and every API, I can run all of the test logics that active testing offer over these APIs. Why is it important to have your complete coverage? For example, business logic consumption. Let's talk about an API that returns me forbidden data. An issue that we've talked about before. It returns me a credit card number. I won't be able to understand that the API returns me a credit card number without providing the correct values in the request. So I can see no errors in the response. I can see the credit card number. And this is a complicated part to achieve. And this is what our algorithm does that nobody else does in order to inspect the forbidden data exposure that we want to test. If I'm always encountering an error while trying to consume the API, I will never see that it returns me forbidden data. So if I'll try to make it simple with a simple example, I have here an API, for example, that retrieves me an order details from some e-commerce app, and if I provide here, this is a parameter of an order ID. If I provide here the correct ID, I will retrieve the full order details, which include a credit card number, which is of course forbidden. If I won't put a correct ID here, I will get an error stating order doesn't exist or something like this. So if we'll take a normal desk tool, which is not active testing, that gets the API spec of this API, And this tool tries to interact with the API. What it will usually do is it will take from the schema of this parameter the fact that this is a number, and we'll try to place a number here, like 76. It will return the API, while consuming it as such, will return an error. Order does not exist. And this is where the DAS tool will finish its job, stating there is no forbidden data exposure over the API. The way active testing solves this issue is it understands this API, retrieves details of a resource called an order. And then it finds in your inventory another API that looks something like this, post/new word, or something like this, /create, that is responsible for creating the order. And once calling this API, it will retrieve in the response the number of the order ID that was created, like 98. And only then it will call the tested API that you want to consume with the correct number. It will get the credit card number in the response, and it will state it has a forbidden data exposure issue. This is why reachability is so important. And this is why we've investigated so much in creating these algorithms that allows us to fully test each and every API. And we also bake this into the UI, allowing you to investigate how we consumed each and every API. For example, I can press on this dot and see how active testing did successfully consume an API, why the dot is green, because before calling get/item/item ID, it called automatically post/something/item, which creates an item, retrieves an item ID here, 34, and then calling the API that is being tested. We make sure that every API is fully consumable before moving onward to the testing phase. And the cool part is that if active testing is not able to do so, we easily allow the user to troubleshoot this. If I'll press on a single API, I can go over to the request editor, seeing how active testing calculated how to consume the API, how it builds the request, and change how it behaves. I can change for each and every field how to generate the value there. I can place a dependency, meaning that I should extract the value from a different API, like we saw in the get item, post item. And I can also state that I want a static value there. I can write there, for example, this one, submit, and publish the changes, inspect, of course, how the API reacts, and then save this for future scans. This is the idea of troubleshooting reachability, and this is our aim here, to leave no API untested, both with sophisticated algorithms that does most of the work automatically and enabling you troubleshooting tools. Any questions about that before I continue?
Yeah, Lars there. I'm wondering, is this active testing solution also using the passive monitoring so first in order to learn the behavior from the application, because there can be undocumented API calls and such?
Mhm.
You only see for monitoring.
So we do have, first of all, algorithms that try to predict undocumented APIs by basing yourself on the structure of the detected inventory. I will try to search for other methods. I will try to search for similar words or keywords or from patterns that we know that exist in the world. And also, as I said before, we always transfer data between production and pre-production to try to find more assets.
Yeah, I'd say the production import is pretty important to this to fill this out. I would imagine in a lot of applications, you're going to have a long list of things that are in this category you're talking about here that it didn't work initially in testing and need someone to tweak this. How does the cooperation work between operations and developers to get this to work, to dig into these details? What kind of conversations do you have there, and how much resistance do you get with the with the actual users of this to make this 100% coverage? This seems like it could potentially be a lot of work.
That's a great question. First of all, I want to add a single note about the connection between production and pre-production before I get to your point, and just state that the transfer of data, I missed it from my previous anecdote. The transfer of data has to be super intelligent. I know about tools that offer taking inspiration from production and using the values that you see in the request there and try to use them in pre-production to test the APIs to gain the reachability part that we've talked about. This is, of course, irrelevant for freshly developed APIs, the ones that you don't see in production. So all of these kind of solutions that tell you that they cover shift left are inherently wrong. By understanding the resources, the one that we talked about before, the resources that are being at the center of the application, this is the way you do it. This is the way you handle freshly developed APIs. I just want to state that the transfer of data is should be super intelligently and not just take values from production, which are usually irrelevant in pre-production anyways. This is just the first point. About the ease of integration, about how we are getting involved in the processes of developers and application security personnel. I think we pretty much nailed it from the response of our customers, and this is by separating the experience of the developer and DevSecOps or AppSec. They are required to interact with the UI. You have a static environment, for example, staging.customer.com. You see how you onboard it. You choose the URL, you choose the specs, you choose the authentication, you're done. You can press scan, you can set scheduling. Super simple. For developers, we don't want to interfere with their routine. In fact, if testing is integrated into a certain CI/CD pipeline, I cannot expect them to enjoy the experience of somebody, for example, going to the request editor that we just saw, changing how to interact with the API and expecting the developer to be happy for this. So what we've done is that every CI/CD branch that is being tested is a read-only environment here. I do not allow AppSec personnel to mitigate the requests that are being sent, to mitigate the tests that are being sent. All of the configuration that you saw here is also applicable with configuration file a developer is placing inside their code repo. And this is the cool stuff. Basically, you place a configuration file with everything you can do in the request editor and all the settings required to do the scan. You can branch it out to different branches if you have different authentications, etc., etc. And there you go. You have a complete control for developers. Nobody can interfere with them. AppSec personnel or DevSecOps can inspect the outputs of the scans from the pipeline.